Okay, we're going to do some more problems on 51, and this is number 42, and let's take a look at this one first. And what we notice is we've got a big old fraction over here on the left and one little term on the right, so we're going to try to get the left to equal the right. And if we look at the cosecant, we know that we can kind of write it over here. This is the same thing as 1 over the what? The sine, right? Okay, so we know that. So what we could try to do is try to get everything in terms of the sine and cosine, and then we're pretty close. All right, so let's try to do that. I think that would probably be the easiest way to go at it. So first of all, I'll write everything over here in terms of the sine and cosine, and then that's not difficult. What's the tangent? The tangent is the same thing as the sine of 2 theta over the cosine of 2 theta. We all know that. We use that in our unit circle all the time. And plus, and then the cotangent is just the reverse of that, so that's just the cosine of 2 theta all over the sine of 2 theta. So we all know that. And then we've got a big old fraction bar here. So we've got a big old gigantic complex fraction. And this is the same thing. The secant of 2 theta is 1 over the cosine, right? We've got a big old question mark yet. So take a look at that. So those are just your identities that you know. You know these we use all the time. Sine tangent equals sine over the cosine. Cotangent equals cosine over the sine. And the secant equals 1 over the cosine. So that's just what we know. Now, why did I do that? Well, because I'm trying to get everything in terms of the sine and cosine. So that's one of our basic techniques. So I'm just following those rules. Now we have a complex fraction. Remember I told you when you have these big complex fractions, the easiest way to take care of these things is to multiply the top and the bottom by the least common denominator of all the denominators. So on the top I've got these two, so my common denominator would be the product of those. And here I've got this, but that's going to be covered by that. So my LCD for this whole thing is, I guess I'll put it over here because it's going to overlap. I'm going to multiply the top and the bottom by that LCD, and that's going to be sine of 2 theta times the cosine 2 theta. And I multiply the top and the bottom. So I'm multiplying the top and the bottom by the LCD. That's the least common denominator of all these denominators. And let's see what happens. Okay, so if we multiply, I probably should put a parentheses because we're going to have to distribute here. So we're going to multiply this times each of these. So be careful and watch what's happening now. And again, this is just more algebra, but only instead of x's and y's, we've got sines and cosines. Okay, so when I multiply this term with 2 factors times this, notice how the cosines cancel, right? Because I got a cosine on the bottom and the cosine on the top. And what's left is sine of 2 theta times sine of 2 theta, so I got the sine squared of 2 theta. So take a look at how that works out. I know the 2 thetas are confusing. You know, it's confusing even with 1 theta. But again, I'm multiplying these two, this times this. So don't even look at this other thing in the middle. Let me cover that up. So if I multiply this times this, it's like if I multiplied x over y times x times y. All right? The y's would cancel, and I'd have x times x. So you could think of it the same way if you want to do that. And sometimes they just put these things in x and y, and they work them out, and they resubstitute at the end. Okay? So everybody get that? I'm multiplying this times this. Cosine over cosine cancel. I got sine times sine is sine squared. Okay? And there's a plus sign because then I'm also going to multiply this times this one. And this is a little bit easier to see because they're next to each other. In this case, the sines cancel, and what do I have? Cosine times cosine. Now we all know what this is, right? This should just smack you in the face and say, here I am. Number 1. Okay? All right, and then what do I have over here on the bottom? Well, I got to multiply the bottom by this. Sorry, I almost forgot to do that. That would have been a tragedy. And here the cosines cancel, don't they? And what's left is just a sine. All right? So make sure you follow what we did. Okay? Put everything in the terms of the sine and the cosine first. And then we had a complex fraction, and don't be afraid of these. We just multiply the top and the bottom of this complex fraction by the least common denominator. Something that will take care or cancel all these denominators in one fell swoop, so we don't have any more complex fractions. Just one numerator, one denominator. Okay? And what's the sine squared plus the cosine squared? Our old friend number 1. That's our Pythagorean identity. So I've got 1 over the sine of 2 theta. And what do we say that was equal to up here? There we go. So we're checked. We got our verification. Okay, I hope that makes sense. All right. Okay, then we're going to do number. Well, I've been spending a little bit of time on the next problem, so I guess we'll just do this one for right now. Okay. Again, think about that. It wasn't long, but there's like a lot going on as far as your understanding of algebra and complex fractions. All right. So just think about that one, and I hope that helps.